My name is Zach. I am the CEO of Particle. We're an Internet of Things platform. I'll talk a little bit more about what that means, and the goal of this presentation is really to talk about what are some of the lessons that we've learned along the way as we've built this company. We've been in operation for about 6 years, which, as far as companies go, makes us pretty young, but in this industry makes us sort of old hat. We've been at this for kind of a while, and have learned a lot of really valuable lessons along the way, so happy to share them today. So first, what is Particle? So we say we're an IoT platform. That is two buzzwords piled together. What that actually means is we're in the business of helping people bring products online. So our customers are companies that typically manufacture some kind of physical product. It might be industrial equipment. It might be consumer products. They're the kinds of companies that know how to make widgets but don't necessarily know or have experience building software. And so we provide all the things that they need to get their products and their assets online. Specifically, what we give them, we call our platform an all-in-one IoT platform, which is to say we do a whole bunch of things that typically would come from different companies. So we start with the hardware. We give our customers Wi-Fi modules, cellular modems that go inside their product and actually physically add a radio and get in order to get it online. We also provide connectivity. That mostly means in the context of cellular. I got a whole thing here. In the context of cellular products, we provide SIM cards and data plans. We're what's called an MVNO, a mobile virtual network operator. That means we're a carrier, but we don't have our own towers. And we do networking, security, the whole sort of communication stack. We provide a device cloud, which is the servers that the devices connect to, because once they're connected, what are they going to talk to? Our servers secure the connection between the device and the cloud, expose everything through an API, and give our customers the tools they need to manage and oversee these products. So you can log into a console, you can see all your devices, see which ones are behaving, which ones aren't, push out software updates, things like that. And then we provide tools to build the applications that their customers use to interact with these products. So mobile and web applications that you would use to control one of these remotely, or to control them en masse, or to read data off of them, whatever it might be. We provide the SDKs our customers use to build that. So we do a whole bunch of stuff. Now, we also support a pretty wide range of customers that do a lot of different things. Examples of companies that use Particle. Opti is a company that makes a stormwater management system. So this is a solution for cities whose stormwater systems can't handle the amount of water they're getting as weather becomes more extreme and there's more rainfall. If that's the case in your big city, what do? Well, you can't build a bigger sewer because that would be very expensive, and you probably don't have the budget to do that. So you can get a smarter system that moves the water around in a more intelligent way, where it takes weather forecasting and basically moves water in advance of storms happening. So if there's going to be a flood tomorrow, a flash flood, you can empty out the reservoir in advance so that instead of overflowing and destroying the neighboring roads, it just fills back up. Canary Compliance is a company that has sensors that they attach to the tanks underneath gas stations to make sure that they don't leak. Or rather, if they do leak, it reports it back to them, and this is in order to be compliant with EPA regulations around gas stations. Probably not something you've ever thought about. When you go fill up gas, there are tanks under there, and you obviously, if you are the neighbor of the gas station, you want to make sure that that fuel is staying inside those tanks. And so we provide the connectivity they use to connect those to the internet and make sure that they're behaving as expected. And then in the consumer world, Jacuzzi, manufacturer of hot tubs, they're connecting their hot tubs both so that they can let you control it remotely, so you can make sure the heater's not on unless it's needed, and when you're ready to use it, you can turn it on from your phone. But also to make sure that the quality of the water is always good, so they'll have sensors that can detect when the chemistry levels need to change and automatically give you the chemicals that you need. So those are some of the kinds of companies that we power. It's pretty broad. We're the most widely used IoT platform. I have 140,000 people building products with Particle. And over the last 6 years, we've learned a lot. So I just wanted to share some of the lessons that we've learned in building this business. And I'll start with a little bit of history. We didn't start as a platform company. We started as a product company. Originally, we were called Spark, and we were trying to connect light bulbs. The inspiration for this product is that my dad is deaf, and I wanted to make his lights flash when my mom sent him a text message. And my thought was, well, if only the products that we had in our homes, these smart products that we were starting to build at that time, this was 2012, so Nest was just becoming a thing, if only they had APIs. If there was an API, a software developer could create an application to solve a different problem than the one that was intended by its manufacturer. So we attempted to launch this product on Kickstarter in 2012. It was an unsuccessful product launch, and not knowing what to do next, we flew to China. We were invited to join a program called HAX, which is a startup, an accelerator for hardware startups based in Shenzhen. We lived in China for a few months, and while we were there, we were surrounded by other entrepreneurs who were trying to build similar kinds of products, and this massive ecosystem of manufacturers in China, all of whom wanted to do this kind of thing but didn't really know how, and they were all struggling with the same technical challenges. So we thought, well, everyone seems to be tripping over the same things. What if we rip the guts out of our product that we've already built and sell it as a solution to these other companies instead of as our own consumer product? And so we relaunched with a second Kickstarter campaign 6 months later for a development kit called the Spark Core. We had a $10,000 funding goal. We raised almost $600,000 and found ourselves with 5,000 customers in this burgeoning developer community of people who were building IoT products. And we really started with this idea that said, every product starts as a prototype. And so if we want to be in the business of supporting companies as they build these IoT products, let's get in at the prototype and then support them through their entire journey. Because when we think about what success looks like, it's shrinking this time frame as much as possible. So the day you draw on a napkin the product that you want to create to the day that that product is delivered to customers, we'd like to see that happen in 6 months instead of 3 years. So typically the way our business works is an R&D engineer buys one of our development kits. We've shipped hundreds of thousands of development kits around the world, and they use it to build a prototype. They may or may not be intending to do this at scale. They may or may not have budget, but they're sort of figuring it out as they go. And then once they realize, oh, this technology works, then they go do a pilot to figure out if it sort of makes business sense, right? Can we actually collect the data we need to solve this problem? Does it fit within the power budget? Is it cost effective? Are we going to make money? Those kinds of things. Will customers pay for it? And then if all that works, they deploy it at scale. And the scale might be 100 units or it might be 1 million, depending on what size company it is and what kind of thing they make. What we ended up with was something that looks very different from most companies in this space. There are a lot of companies that make IoT platforms. Depending on who you ask, somewhere between 200 and 450. And so you think, wow, that sounds really competitive. Well, it is if what you mean when you say IoT platform is a data and analytics toolkit, because that's what most IoT platforms are. In a lot of cases, they were pre-existing products that were really like big data products that say, we'll suck up all your data, we'll analyze it, we'll solve some problem for you that got an IoT sticker stuck to them. And so there are many of them, a lot of big companies, and it's a very competitive space. Now, there's a whole other kind of platform, which is a device platform, which is really what we do. We're not in the business of solving problems with your data. We're in the business of getting your device online in the first place so that you can get the data out from it. And there are not very many companies that do this. There are a small handful, and we all are pretty different from one another. So even though, in theory, we're competitors, it's very uncommon for us to even be talking to the same companies and for us to be competing with one another. And so we ended up in this really interesting place where what we built was, to be honest, kind of a pain in the ass to build. We do all this hardware stuff, this software stuff. It's not an easy thing to make. We then have a pretty large market, which is every company that has not yet made a connected product but wants to, which is most of what IoT is right now, because this is such a young market. There are a lot of physical product manufacturers that haven't brought their devices online yet but intend to over the next few years. Our products are highly differentiated, meaning there aren't that many of us, and we just operate differently, so it's easy for customers to figure out which one of us they want to be working with. And so we're not that competitive. We don't bump into each other. Whereas if you do what most people do in this space and focus on data, you end up with something that has a limited market because you can only sell to companies that have already connected their devices, which is relatively smaller. The products end up pretty commoditized and pretty competitive. So it ends up being that we found ourselves in this place where we've built a good business, mostly because we didn't think about the technology we wanted to deploy. We didn't say, oh, there's value in the data, so let's go do data. We said, there's a problem to be solved here. It's really hard to get your devices online, and we can solve that. We can fix that, and that's valuable to our customers. And as a result, we've built a strong business. Okay, so second thing, given how I've described the business, I'd be curious to ask, how many software engineers do you think our typical customer has? Just throw out some numbers. 0? 2? Yeah, so 5. So our customers, if you have a 1,000-person company, they probably have one software engineer. It's probably a mobile developer, and they probably built their mobile app. As a result, the way that we engage with them is not the things we build for them are not necessarily the things that our engineers would want to build for themselves, right? So things that matter to our customers. It should be really easy to use. There should be next to no work to get this thing online, to get it set up, to get it integrated with the other systems I use. The security should be built in. I shouldn't have to think about security at all. Please tell me that you've taken care of that already, because I probably don't know anything about security. We have to provide really great support, really good professional services. If you have a problem, we show up, we fix it. And we have to be perceived as experts, because our customers don't necessarily know enough about IoT to even ask good questions to evaluate whether our technology is right for them. They're trusting us to say, like, we can actually solve your problems and we are actually a good fit for what you're trying to do. They're also trusting us to tell them if that's not the case, where if we're not actually a good fit, that we will tell them, I'm sorry, you should go do something else because we're not a good fit for you. And some of these things are not really what we would build for ourselves. Our engineers like to build engineering tools. They like to build tools that they would use. Well, we have really good engineers who like to use a certain kind of thing. They like to use Vim, right? They work in sort of deep tech, in the deep tech space, and so they often our intuitions about what we should build are often wrong, right? We have to be asking our customers very carefully, what is it that you need, instead of just trying to build a product that we would want. So lesson number 2, you're not your customer. And the last lesson here, I want to talk about one of our customers, and one of the challenges we had with the company, which is we had a customer making a leak detection system. And the idea was, this is a product that would be installed on the water pipe coming into your house, and it could detect leaks, and if one was detected, it would shut off the water so that you don't end up with a flooded basement. And basements that flood due to burst pipes are one of the most common sources of homeowners insurance claims, especially in colder places like the Northeast. So, okay, makes a lot of sense, right? And this was our first multi-million-dollar contract. We were really excited about it, and saw this as this was in a lot of ways like our first enterprise customer. But the problem is it didn't work out that way. We did have a large contract, but for a bunch of reasons, their business didn't actually work all that well. And we were faced with this challenge. Well, okay, but they signed a contract, right? Well, it doesn't really matter if they signed a contract if the business isn't viable, right? Because what are we going to do, right? So we realized it's really important for us to think about, as we engage with our customers, what is their business, right? And how do we filter for businesses that we think actually make sense and have a good chance of being successful so that we're investing our time well. So we built a framework for thinking about how people make money in IoT. We realized when we looked at our customers that had showed up over a year or two, that there were some pretty clear patterns of how they made money. And we sort of narrowed it down to these 6. Regulatory compliance, so if I have a natural gas rig and it produces methane as a byproduct, the EPA says that the methane emissions can't be above a certain amount. So I need to track that. I need to figure out how much methane I'm producing and tell the EPA that I'm below that number. So that turns out to be a great application for IoT, is putting sensors on things to make sure that you are in compliance with the regulations that are put on your industry. Consumables replenishment. If I have a thing that consumes oil or filters or fuel or coffee pods or any other thing along those lines, those consumables get used up, and when they're gone, you want to have more, right? So there's in many cases an opportunity to build a business saying, well, we'll keep track of how many consumables you've used, and we'll ship back more to you when you're done. And I know I'm at my time, so I'm going to sort of say there are more of these. There are more ways that people make money, but knowing this, we apply this framework when we start talking to a customer. Oh, by the way, smart devices, which is to say I make a widget and it costs $50, and I'm going to make a smart widget that costs $200, and I'm going to sell you that instead. Terrible business. Don't do it. Unless you can figure out other ways to create value besides that, right? So if you say, well, I'm going to sell you a smart device, and also I'm going to build a consumables replenishment business, well, that's interesting. We can talk about that, but be very careful about building just straight up smart devices. So we end up building this model when we talk to customers to say, well, here are all the ways that we typically see people make money in this. How might you? We often find out things. These are some examples from some of our customers like, oh, you have a warranty. Well, how long do you warranty the product? Okay, it's a 5-year warranty. When do you start the clock? So you might think, well, of course, when they buy the thing. Well, sometimes it's not you who sold it to them. It's a dealer or a distributor. So you don't actually know when the product got bought. So you might not start the clock on the warranty until the first time they request service. Well, now it's not a 5-year warranty, it's something more than that. Maybe it's a 6-year warranty, it's a 7-year warranty. That costs you more money than providing a 5-year warranty. So if you knew when they started using it, because it's internet connected, the first time it comes online, you start the clock, that means you're actually giving them a 5-year warranty. So you can save money by reducing it to 5 years, or you can make a happier customer by giving them a 6-year warranty or a 7-year warranty. It doesn't cost you any more to do that. So these are the kinds of things we find with customers. We sort of work through this checklist and say, where might there be a business here so we can help tell a story of how you're going to make money so that we know that there is a strong business here and you're actually going to keep doing this. So, lesson 3, make your customers rich. If you're in the business of building a B2B business, what you want is your customers to be wildly successful using your technology. Because if that's the case, it's really easy to sell to the next set of customers who come in and say, I heard about what you're doing with customer Y. I want that to be true for me too. Let's work together. What can we do together? So, some of the lessons we've learned along the way, and I've got just a couple minutes for questions.
Thank you. Awesome. So just one question from me. Same question as for say, where is the space going? Where is IoT going after all of this?
So it depends on what time frame, I guess. So IoT is a weird industry because what we're saying is it's a catch-all, right? It's like everything that would be internet connected that isn't a PC or isn't a smartphone is sort of classified into IoT. And so what you end up with is 75 different industries that we've sort of lumped together. And when different people talk about IoT, they talk about different things. IOTAS is thinking about multifamily homes, right? And some of our customers are thinking about gas stations, right? Totally different worlds. I think it's fair to say that over the longest period of time, as the cost of compute, as the cost of connectivity comes down, as the power consumption requirements come down, eventually everything will be connected, or everything of some value will be connected for some reason. I think it'll take us a while to get there. It feels like in IoT we're in 1979 or something like that, right? It's like PCs are sort of just kind of a thing recently, and there's a lot of stuff coming in the next 30 years that you can't really see. We're sort of pre-operating system days, so we haven't really hit critical mass yet. So there's a lot to be excited about, and there is a business today, but I think it pales in comparison to where it will be decades from now. I say that not having actually lived in 1979, so if anyone was around then and wants to confirm that that's what it felt like or not, let me know. Disco? Is that? Yeah.
Hi, actually I have several questions. Personally, I use the particle a lot.
Awesome.
Yeah, and first question is a little bit light. Personally, I feel like Electron is very good, but I feel a little bit costly. Do you guys have any plan to lower down the price? You know that listen, the huge mistake Intel Edison made, right? They were just too expensive. And that's the first question. Second question, and speaking about the computational performance of the board, and I really want to know why you choose the Cortex M3 as the microcontroller for the photon and the electron. Is that the main reason is because the target market you have in your mind when you pick up that one? And also I want to hear your personal comments, like how you picture the competition coming from other competitor, particularly Blink, a chip. And chip, they use much better microprocessor, PU, way better than what you have. And for example, like sometimes I do want to develop some advanced, some project which involves some advanced computational algorithms and push the data, a lot of data to the cloud, not just like temperature sensor, like say some imaging capture by the camera. So apparently the electron and the photon cannot handle that. Do you have any plan, a future plan to, to put a higher end like processor?
Yeah. So, a couple thoughts. So one is, the electron, why does it cost so much? So cellular chips are still expensive. And you mentioned the Edison, right? Which, if you're not familiar, Intel developed a chip called the Edison that they pushed really hard. They spent hundreds of millions of dollars pushing it. They completely shut it down and killed it. So it doesn't exist anymore. So, okay, not a thing we want to replicate. Now, the difference is, though, the Edison was a Wi-Fi connected product in a world where Wi-Fi connected products were very cheap. So it was not successful because it cost 10 times as much as anything else in that space. With cellular stuff is just expensive. So in the context of cellular, our stuff is very affordable and is typically the cheapest thing out there for a fully certified product. For what it does, it's the cheapest thing you can buy. Now, that doesn't mean it's still much more than Wi-Fi, significantly more than Bluetooth. But if what you want is cellular, it's a good fit. And the second thing was about microcontrollers versus microprocessors. And I think, I'll speak broadly about IoT. There are two different worlds of IoT. There are things that are powerful that require a full processor, and there are things that are lower cost, more real-time systems, and in many cases more power constrained that use microcontrollers. So we focus on microcontrollers in part because we think that's where there is the least available good technology. If you use microprocessors, which basically means you're using the same thing that would get installed in a server rack somewhere, there's a lot of good software that will solve problems for you because you can run the same software that you can run on your own PC or in a server. You can run Linux, you can run all this great stuff. In the microcontroller world, there is none of that, right? The quality of software that exists today is total garbage. And if we're in the business of saying there's a hard problem here, we want to make it easier, we like to chase the hard problems. Now, that means that we can't do images, for instance. Like, media is just totally out of scope for what we do, but that's a choice to say we do microcontrollers, we focus on sensors, we focus on actuators, we're really good at that. And if you're doing something else, then there are better solutions available.
Cool. My questions are mostly around data. You had mentioned that you're not particularly interested in it right now, but is that something that would change later? Because I imagine some of your clients would have interesting insights in the data that they're collecting, and maybe that's something that you could use as an additional cell or something.
Right. So it's a great question with a complicated answer. So right now we don't really do data. We help you get your data out of your device and then put it wherever you want it to. And I'm not going to claim that was that was a decision we made up front. It was more like we had some number of people available, so we built the stuff that we could do in a reasonable period of time, and that was a thing that we hadn't built yet. Now, what ended up happening is that this turned out to be valuable for a lot of our customers because the data ownership problem. Our customers want to own the data. So they're very careful about, they don't actually necessarily want us to handle the data for them because they really want to own the data and feel like, and the way that people feel about how they own their data is maybe different than whether they actually own their data. Because there's something about you feel like if you use AWS that it's your data. But if you use another vendor, it wouldn't be your data, which feels a little weird. But regardless, there's this perception issue around ownership of data. So it has turned out to be a benefit. What we can say to our customers, like, you own your data, not ours. It will be encrypted as it passes through our servers, and we will hand it to you, and then you can do what you want with it. Now, it's not to say that we don't have value that we can create there, and we do have plans to provide more solutions there, but they'll be optional, so that you can say, like, you can hit a button and we'll say, like, okay, we'll just take care of that for you. But you can also continue to use your own data service providers, because we don't want, when people perceive so much value in the data, I don't want to take that value away from them. We're in the business of supporting our customers, of helping them be successful, and I don't want anything to block that. So as a result, we're sort of tread carefully when we go into that. Okay.
All right, Zach, that was wonderful. Thank you.
Thanks, everyone.